Okay, welcome back. Today I'm going to show you how to program the tic-tac-toe foot in Fusion using manufacturing. Stick around, it's going to be revolutionary. Okay, so we have the foot. We've already switched into the manufacturing workspace. We need to make sure we've already downloaded the ST10 tool library, which has a general facing turning tool, a parting tool, an OD threading tool, and then we are not going to use tools 4 and 5 for this project, so we only need those first 3. So if we have that loaded, okay, our first thing is going to be setup. So we go ahead and select the setup. The part is going to be in the lathe like this, where our Z positive is to the right, our Z negative is to the left. So our origin's completely in the wrong place. So I'm going to check the Z plane here. Oops, there. Let's cancel that and let's go right there. And then we're going to flip Z. That'll bring it around to this side. The X, because it's round, doesn't really matter. We are going to select the body, which is that. Oops. It already selected that. There we go. And the chuck reference we will come back to in a minute. So our stock is going to be a fixed size cylinder. It is going to be 0.75 in diameter. And its length will be 3 inches. And its offset is from the front. We want to offset it like 0.02. So it's just barely inside the material. Now, okay, so now we have it set to 0.02 off the front. We need to establish where the chuck is, which is this green circle here. So the part is length is 0.675 plus 0.02 makes us 0.685. And then we need to subtract that all from 2 inches. So if we flip back over here, the chuck is a negative 1.315 from our part, and that means the chuck is a good distance away. So we're pulling the material out 2 inches to make this part. Our last step is we do not worry about work offsets in lathes. We just put in our number here, which has to do with our birthday. And we click OK. So now we have the setup done. Our next step is going to be to get our first operation, which will be a facing operation. So we go ahead and click facing. We are going to select our tool, which is going to be our general facing turning tool, tool number 1. We are going to just pretty much come across and hit OK. And it should make a nice facing pass, which you see it does right there. Now, our next step is we need to do a general material removal by getting rid of all this stock. So we are going to do a roughing. We are going to let it select the same tool. We are going to go to geometry, and there's the geometry. And we are going to, it's showing us the clearances. We are just going to click OK and see how this comes out. And there is our removal of the material, most of the material away. We are going to do a cleanup pass, which will be our next step. So we'll do finish profiling. Now, under geometry, we need to actually change the back of the model because our problem has to do with this chamfer. So we are going to go from back to selected, and we are going to select that ring and click OK. We also need to change under the lead in and lead out. We have to change it from 45 to 90 degrees so we don't get an error. So we now have our facing, our rough turning, and our finish turning of our part. So the next step we need to do is we need to cut this relief. The next thing we have to do is cut this relief groove. And you will notice also, because our cutter has a small radius on the tip, there's a radius being presented here and here. And to eliminate that, we are going to use our parting tool to come in and clean up that little edge. So let's go ahead and do that. So we are going to do a single groove. There we go. We are going to select this edge here and this edge here. we have to go change to our, I should have done this first, our parting tool, which is tool number 2. And then we need to come across to middle. We want to do it from the front side because that is where we selected the contour. And if we click OK, it will notice that we give us a nice 90 degrees as well as that relief there so that when we thread, our threading tool has somewhere to stop. So that's done. Next step is threading. So let's go in here and go to threading. This will require a bit of math. We are going to have to switch to our threading tool, which is the OD outside diameter threading tool. We're going to select that. We're then going to go to geometry and we're going to select this face where the threading occurs. And it's going to ask us here, let me flip it over so we can see it. How much are we going to start at the beginning? 0.2 is probably more than we need, but we do need to add a little bit to the back. And I'm going to do 0.05 and I'll talk to you why 0.05 in a minute. Now we come across to radius, stock, offset, all that should be fine. And where is it? Okay, so now we need to do a little bit of math in order to figure out the thread depth, the number of step downs, the pitch, and all of that. Okay, the threading we are doing is going to be a 1/4 20 thread, so a 1/4 20 thread. So really quickly, 1/4 translates to 0.25 diameter. That's the outside diameter of the threads, and 20 represents 20 TPI, or threads per inch. Now, the first thing we have to figure out is what is the minor diameter of a 1/4 20 thread. And I believe it is 0.196, which you can look up in a reference book or on the internet under minor diameter. So we're going to take 0.25 and minus 0.196, and that is a 4, 5, and a 1. And then we need to divide that, no, I'm sorry, 0. So 54, we have to divide 54 thousandths in half. That comes out to 27 thousandths of an inch, which will be the depth of our thread. So if we jump back over to Fusion, this thread depth, which is done in radius, is 0.027. Normally, I want this to be about 5 thousandths per pass. So 5 times 5 in this case is 25 or 25 thousandths, which is very close to 27. So we're going to leave it at number 5 step down. So the next thing we need to do is thread pitch. Pitch on this thread, if you have the V's, the pitch is from the top of one V to the top of the other, this distance. Or the bottom of one V to the bottom of the other, they should be the same. Now, so how do we get the pitch? Well, there are, let me erase this so we can get some space. There are 20 ridges in 1 inch. There's 20 in 1 inch. So we take essentially 20 and divide it by 1, and it works out to 0.05. So the pitch, the distance from one ridge to the other, or one valley bottom to the other valley bottom, is 0.05 inches. So if we come back over here, our pitch is 0.05. Now, if you mess this one up, your threads won't be deep enough and it won't screw in. If you mess up the pitch, you will not get the right number of threads per inch and it won't screw in. So this is a very important table. But now we are done. And a lot of this is once you learn the common sizes, this becomes very, very easy. And we click OK. So we now have this done. So our last step is to do this backside chamfer and part it off. So for that, we're going to use the parting off tool. And let's get it around to a place where we can see. And we are going to come over here. It already says, oh, we probably want to do the backside chamfer, but we want to do this edge break. Now, this edge break has to do with moving it back, and I believe I have pre-calculated this for us. For our tool to do an edge break, we want to do 0.1 0.05, and that will give us the proper edge break that we want, and we click OK. And what you will see is when we simulate this, which I will slow down. Well, that's a little too slow. There we go, the facing turning. Now it's going to do the profile turning, roughing, I'm sorry, profile roughing. The finish pass. So now we're going to come in and clean up our groove, then clean up that corner, come in and do our threading. And now come in and do our parting off. So it gives a starting part off, then comes in at an angle and cleans up our edge and falls off. Now the only thing we need to add to this is we're going to add some manual inputs, because on the lathe we need to control chips. So we need to get the chips out of here, mainly because when we actually part it off, this is going to fall on the bottom of the lathe and we need to find it. We don't want to have to be digging through chips for it. So what we are going to do is we are going to do a manual NC. And our first one's going to be start the chip transfer, which in our case is a chip conveyor. So we click OK. It's going to put it at the end. I'm going to drag it to underneath the facing. No point in starting to move chips out of the way if we haven't actually moved chips off the part yet. And then we are going to do another one, manual NC, and we are going to go to stop chip conveyor. And this one we are going to slide to right in front of the parting so that our part doesn't get carried away in the chip conveyor. It'll fall down and the chip conveyor is no longer running. So once this is done and it looks good, which we already simulated, we can go ahead and post-process. So we're choosing an ST10 from this list. We are putting down our number, we are putting down our name, and we hit post. And there is the lathe code for the foot project. You'll go out and run it on the simulator and then see me about running it on the machine. Thanks for watching. Hope you learned something. I'll catch you in the next one.